Hello students, welcome back. So we were studying current electricity. We have studied about charge, then rate of flow of charge is what is current. So how can current can be formed? So I is equal to Q by T, and if the charge flow is varying, then I is equal to dQ by dt. And then the current due to electrons, current due to ions, all these things we have studied. Just we will have a quick recap. So if the charge flow is constant, I is equal to Q by T, then I is equal to dQ by dt. If the charge is varying, if the charge is a function of time, if we get charge like t square plus 3t, something like that, if we get, then we will be solving like this. Then I is equal to the charge flow due to ions plus charge flow due to electrons divided by t. So based on the direction of movement of charge, we will be putting either plus or minus. We have done that. Then we derived the equation for drift velocity. So Vd is equal to E divided by m into tau, the charge, electric field, mass of the carrier, charge carrier. Then what is this? Tau, average relaxation time. Then the relation between current and drift velocity, I is equal to NEA VD. This is number density, the number of charges per unit volume. Then E is charge, A is area of cross section of the conductor, VD is the drift velocity, and thermal velocity with which the electrons will be moving will not give us any current. Drift velocity is the velocity of average velocity of electrons or any charge carriers when we supply a continuous electric field by applying a suitable battery to the conductor. So this much we have seen. We have done some problems also. So we will continue from here. So regarding drift velocity, we will do some problems first. So here a question: a conducting wire of cross-sectional area 1 centimeter square has 3 into 10 raised to 23 per meter cube charge carriers. If wire carries a current of 24 milliampere, the drift speed of the carrier is. So here the equation is current is given, drift speed is asked, number of charge carriers, area of cross section, everything is given. So NEA VD. So VD is equal to I by NEA. So I is equal to, VD is equal to drift velocity, VD is equal to I, 24 milliampere, 24 into 10 raised to minus 3 divided by this is what? Number density, 3 into 10 raised to 23 per meter cube is given. So 3 into 10 raised to 23 we can write here, 1.6 into 10 raised to minus 10 raised to 1.6 into 10 raised to minus 19, 10 raised to minus 19. Then what is the area of cross section? 1 centimeter square, 1 into 10 raised to minus 4. Converting all the units into SI units, we can substitute like this. So solve this, what answer you are getting? So 5 into 10 raised to minus 3 meter per second. Option B we will be getting as answer. Okay, so this is another question. A wire has a uniform cross-sectional area, a steady current I flows through it. Which one of the following statement is correct? So they are saying figure is given. So a uniform, a steady current I flows through it. So what will happen to the drift velocity? So current will be constant here. So in order to maintain current constant, what should happen to the drift velocity? That is the question. So these are the options. Drift velocity is constant, drift velocity increases from A to B, drift velocity decreases from A to B, drift velocity speed varies randomly. So if we take the formula, I is equal to NEA VD. This is the formula where current is constant. So here area and drift velocity, N is constant, charge E is constant, all these are constants. So if drift velocity comes this side, what will happen? When area increases, drift velocity should decrease because they are inverse proportionality. So which answer should be correct here? Which option? Option C. Now we will study about current density. Current density. It is denoted by the letter J. So current density J is nothing but the current flowing per unit area. Okay, say J is equal to current per unit area. So I by A, the current passing through unit area, this is what is current density. Now suppose if we take a conductor like this, if the area of cross section is A, if the current passing through this is I, then J is equal to I by A. Suppose if we take an area like this, see, if the conductor is like this, I am taking the area, my hand is the area. So the area is standing like this. If I assume a conductor, suppose if this is a conductor, if I cut like this, not like this, if I cut like this, then this conductor's area will be like this. So area will be like this. So if I draw a normal to area, how can I draw a normal to this area? My palm, this is the normal to the area. If I keep the area like this, this is the normal. So can you tell me, my dear students, like area is a vector or a scalar? About area we have studied. So area is a vector or scalar. Let me tell you one thing. Area is a vector. And what is the direction of area then? If my palm is this, what is the direction of this area? Draw a normal, that will be the direction. The direction is towards you. Or I can take this direction also. But for one problem, if we take direction of area specifically, then we should not change the area like once like this, then again changing to this area. That should not happen. If we take area like this, then we should take this as area throughout. So if the area is taken like this, then this will be the direction of area. So if we take this as the direction of current, then if I take this is theta, then this is the direction of area, that is area vector. So here in vector algebra we have studied, if this is a vector f, and this vector f is at theta degree with respect to horizontal. Then how can I resolve this vector? I can resolve this vector into horizontal and vertical direction. I can find the effect of vector in horizontal direction and vertical direction. See, when my hand is this, so if someone pulls my hand in this direction, see, my body is moving in this direction. Actually, my body is tilting in this direction, and at the same time I am moving upwards a little. So when a force is applied in this direction, I have the effect of force in horizontal direction also, in vertical direction also. So how to find this horizontal component of this force and vertical component of this force? This we have studied in the +1 first year in motion in 2-dimension chapter. So you might be knowing. So suppose if you do not know, I am just mentioning this. If you understand this, then only you will be able to catch this topic. So I am telling, if this is theta, then this is going to be f cos theta, and this is going to be f sin theta. If the theta is given like this here, then this should be f cos theta and this must be f sin theta. So if I resolve this vector, then I will be getting this as, this will be a cos theta and this will be a sin theta. So a cos theta direction is that, a sin theta is this. So the area, if this is area, if this is area, the normal to area is like this, then the direction of area is this. So area is this, direction of area is this. Now if the direction of area is that, then this will be the area. If direction of area is this, this will be the area. Hope you got this. Okay, if this is the area, direction of area is this. If this is the area, direction of area is this. If this is the area, direction of area is this. So we have marked the direction of a horizontal direction, vertical direction we have marked. So a cos theta is one direction, a sin theta is another direction. So the area concerned with a cos theta will be like this, area concerned with a sin theta will be like this. Okay, now if you understand this, then things are easy. Now if the current is passing, current density is nothing but current passing through unit area. Current passing per unit area. This is what is current density. So that is why we are dividing with the area. So current is passing through which area? That is what is important here. So when I take a cos theta, current is passing through this area. When I take a sin theta, this area is like this. So no current is passing through that area actually. When I keep like this, all current will be passing like this. When I keep like this, see, current is passing, current is passing, current is not passing through this area, current is passing like this. When I take this area, current is passing like this. Hope you understood. So I am going to select here what? A cos theta. So current density J in this situation is I by A cos theta. So I can write I is equal to J A cos theta, or I can write I is equal to J dot A. So J is a vector, A is a vector. So current is nothing but J dot A. So current density is a vector. Current density is a vector, area is a vector, and current density is a vector. Current is not a vector. We have discussed in the last class. Current is scalar, or maximum we can say current is a tensor. So here I is equal to J A cos theta. So vector algebra, a physical quantity into another physical quantity into cos theta. If they both are vectors, then we will be getting a scalar result. So dot product of two vectors will give scalar result. Okay, scalar result. Here scalar result I is a scalar, j is a vector, a is a vector. So this is how we can relate current density. Pause the screen and note it down. So current density J is equal to I by A, and I is equal to J dot A. In some books it is J dot S. This S is nothing but cross sectional area. So J dot A, or we can write J A cos theta. What is this theta? Theta is the angle between current density and area vector. Okay, so current density is also vector, so this comes JA cos theta. Okay, so here if this is varying, then we will be integrating. I is equal to integral J dot A dA. Okay, we will be, if the area is varying, then the current we will find by integrating integral J dot A dA. Okay, note it down. So here in this conductor we can see area of cross section is constant. So everywhere area is same. Okay, so here current density is equal to I by A. This is going to be constant everywhere. Suppose if we take a conductor with a varying cross section, suppose if this is A, this is A dash, suppose if we take another place A double dash, then here current density J is equal to I by A. Generally current will be constant. So when current is constant, this area will be varying, so current density will be varying. So current density J is equal to constant at a particular cross section. Current density J is constant at a particular cross section. If we consider this is going to be J double dash, here this is JA, here J dash. So current density will be constant at a particular cross section, but if the area is varying, it will be changing throughout. Okay, so here another question. I'll read out the question. A copper wire of length 1 meter and radius 1 millimeter is joined in series with an iron wire of length 2 meter and radius 3 millimeter, and a current is passed through the wire. The ratio of current densities in the copper and iron wires and the iron wire is, they are asking the ratio of current density. So ratio of current density through copper, JCU by J iron is equal to I by A Cu divided by I by A iron. So here current is constant, so we can cancel that. So area of iron divided by area of copper. So radius is given, we can give like for iron the radius is 3 millimeter, so pi into 3. Copper is also given in millimeter, so I am not converting into its units, not into SI units. Then pi into copper, how much? 1. So pi will be cancelled off. We will be getting 9 by 1. So answer is B. Now some more details of current density. How we can connect current density with the conductivity, all those things we will see now. My dear students, see, I is equal to NEA VD. Current, number density, charge, area of cross section, drift velocity. Now I by A is what? Current density, I by A. This is equal to NE VD. So current density J is connected with the drift velocity with this formula. So already we know drift velocity is EE by M into tau. Then VD is equal to, from this equation we can write I by NEA, and another thing is VD is equal to, this I by A is current density J by NE. Okay, so this is the relation between current density and drift velocity. So remember all these relations with the proper understanding. Again, coming back to the same equation, I is equal to NEA VD. So here for VD we substitute EE by M into tau here. So I is equal to NEA EE divided by M into tau. So bringing this I here, I by A is equal to nothing but current density J. Current density J is equal to NE square. NE square we have taken. A has gone here. Then E, instead of E we'll put tau here. Then E divided by M. So here we know current density J. So here all these are constant. N, number density is constant. E square is constant. Mass of the charge carrier is constant. Average relaxation time is also constant. So we can say current density J is directly proportional to electric field E. So what about N E square tau divided by M? This is what is called conductivity. Conductivity. So I can write J, current density J is equal to sigma into E, where sigma is the conductivity. So this conductivity is a constant, and constant for a particular material. See, for steel conductivity will have a constant value, and for copper there will be a specific conductivity. So likewise each material will have a specific conductivity. So conductivity is constant for a particular material, and current density J is equal to sigma E, and all these are constant. All these are constant. By putting these values of a particular material, we will be finding the conductivity, and we will mark for conductivity of steel is so and so, conductivity of iron is so and so, by substituting these constant values for that. So current density J is equal to sigma E. Clear? Pause the screen and note it down. So I just quickly revise the formulas. Current density J is equal to I by A. Then J is equal to, from what? From NEA VD. I is equal to NEA VD. So from that this A will be cancelled off, right? A will be cancelled off when we divide with the A. So NE VD. So this is also one equation. Then what is that? finally what we have studied, J is equal to sigma E, conductivity into electric field. Three important relations for regarding current density. So current density, if any problem can be asked based on all these relations. Now let us see again from the basic equation, current and drift velocity, how it is related. From that again we will proceed and we will come to Ohm's law. I is equal to NEA. I is equal to NEA VD. Again we substitute for VD EE by M into tau. So I is equal to NEA EE divided by M into tau. Now what we do, I is equal to NE square AE divided by M into tau. Now how electric field and potential are related? I can write here E is equal to V by L, potential divided by length of the conductor. So we will substitute here I is equal to NE square A, V divided by L, then M is here. Okay, now IV, we have studied V is equal to IR. In your 10th class also you have studied this equation, we have solved problems also. So likewise we will rearrange this. So V is equal to, I is here, what we will do, we will put ML, we will put this side, divide by N E square A, NE square A, then I. Okay, so V is equal to ML into I NE square A. So what is from this and from this, we will understand that R can be replaced by ML divided by NE square A. And so here this M, NE square, all these are constant for a material. For any material, whether length is increased or decreased, whatever we do, mass of the charge carrier, number density, then E square, the charge square, all these are constants. So this is nothing but rho L divided by A. So resistance rho L divided by A. From here we can write rho is nothing but M divided by N E square. M divided by N E square. So this is what is Ohm's law. So from here, by substituting resistance, we are getting Ohm's law. V is equal to IR. What is this R? R is nothing but ML by NE square A, and this constant, when we separate, this is nothing but rho. What is rho? Rho is nothing but resistivity. Resistivity, just like a conductance we have seen, what current density is equal to sigma E. Current density is equal to sigma E. Sigma is conductivity. I already said that is constant for a particular material. So same way resistivity is also constant for a particular material. So how much strong resistivity or how much more resistivity rho is for a material, that much resistance that material will provide while a current will be passed through that conductor. Okay, how much resistivity is there for a material, that much resistance that conductor will offer. Same way, how much conductivity, if the conductivity is more, that material will provide less resistivity. Okay, so conductivity and resistivity are just opposite of conductivity is resistivity. This is what is Ohm's law. So note it down. So a quick recap of what we have studied today. Okay, right from the beginning, the basic theory. One thing is drift velocity E divided by m into tau. Then the relation between drift velocity and current NEA Vd. Then third point, current density J is equal to I by A. So from here, current is equal to J dot A, or current is equal to JA cos theta. JA cos theta. So if that current is varying with the area, something like that, if it is given J is equal to Di by dA, we will have to do same way. If we need to find current from a varying area, then we will have to do just like a J dA. We will have to integrate and find J dA. Okay, these many things we have seen. Another is current density J is equal to sigma E. Another formula is, just avoid this A, NE Vd. Then regarding Ohm's law, we just touched Ohm's law today. V is equal to IR. So R is equal to rho L by A. So here sigma is conductivity, which is nothing but reciprocal of resistivity. And resistivity is formula which we need not by heart and all. Just understand it. Just this will help when we do some problems or some tricky questions in resistance, when we theoretical tricky questions in resistance when we do. These all understanding will help us. So this is the basic theory which we have studied today. One more thing which we will see about is mobility. So mobility is mu. This is nothing but the ease with which a charge carrier can move. Ease with which a charge carrier can move. Just you can think, someone is very heavy, someone is having more weight, so definitely that person will undergo some difficulty in movement, correct or what? If he is trying to jog, definitely he will have to work for some days, he will have to jog for some days, he will have to reduce his weight, then only he will be able to move fast. Someone comparatively, if he is very thin and if the weight is less, then he will be able to move fast. Just for understanding purpose, I am taking this example. So same way, mobility is nothing but the ease of a charge carrier for it to move. So I can write ease of charge carrier to move. This is one point, ease of charge carrier to move. Another thing is drift velocity per unit electric field. Drift velocity per electric field, or we can say mu is equal to Vd by E. So this is the formula for mobility, Vd by E. Okay, so we have studied about drift velocity, relation between current and drift velocity, then current density, the relation between current density and drift velocity, then current density and conductivity, then current, then drift velocity. From that relation we derived Ohm's law. Actually, what is resistivity? All these relations we have seen. So from Ohm's law we have touched the resistance. So now we have to study about resistance, how resistance is varied, what all factors can vary resistance. So all these things we will study in the next sessions. And after resistance, once we touch resistance, then slowly the circuit theory will come. Okay, current, electricity, how we can solve the circuits, all these subsequent parts will be coming next. This is the basic theory. Okay, so we are doing extensive coverage, we are not missing anything, we are touching every part of this chapter. Okay, so revise the chapter today itself and do all the problems and try to do extra problems from the books you have. And if you have any doubts, contact me and you can ask those doubts, we can solve. Okay, so all the very best students. Thank you. Bye bye.